Fischer projection is a two-dimensional structural notation for showing the spatial arrangement of groups with chiral centers. When we talk about Fischer projection, we talk about structural notation, and it contains the different chiral centers of different monosaccharides. D and L configuration would mean dextrorotatory for the right side and levorotatory for the left side. This is an example of a Fischer projection. We have the D-glucose. What we learned, the D configuration means that it is dextrorotatory. And so, we are going to move the highest number of the chiral center going to the right. If it is in levorotatory, we are going to move the highest number of the chiral center going to the left. This is how we are going to do the Fischer projection. For D-glucose, there are a total number of 6 carbon atoms. We have here on top the aldehyde group. This will be carbon number 1, followed by the carbon number 2, 3, 4, 5, and on the 6th carbon, we have a terminal alcohol. This is on the 6th carbon. The next thing that we are going to do for Fischer projection, we are going to divide the line. The one that will be on the left side and the other one on the right side. What is important for this activity is that we are going to locate the D-glucose. If we are going to do that, then we should keep in mind that this will be based on the highest number of the chiral center, and that will be our carbon number 5. So for our carbon number 5, it tells us that we have a D-glucose. Therefore, for our carbon number 5, we are going to put the hydroxyl group on the right side. Now, we are going to complete the structure. For carbon number 2 up to carbon number 4, D-glucose starts with our carbon number 2 on the right side. So we are going to place the hydroxyl group on the right side, followed by left side, and then right side. The remaining pairs will be hydrogen group. So we have hydrogen, 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 and hydrogen. So this is the Fischer projection for D-glucose. We have here an aldehyde group on carbon number 1. Next, our hydroxyl group is placed on the right side of our carbon number 2. Next, carbon number 3 is placed on the left side. Carbon number 4, the hydroxyl group, is placed on the right side. Again, if you want to determine the D configuration, we are going to get the highest chiral center. So the chiral center that is the highest is carbon number 5. Therefore, if it pertains to D configuration, we are going to place it on the right side. And then the last carbon will be an alcohol. Next, in a Fischer projection wherein there is an L-glucose, we are going to do the same. So we will be counting the number of carbon atoms starting from the aldehyde group. Then we continue 2, 3, 4, 5, and 6. Again, for our 6th carbon, we are going to have a terminal alcohol. Next, we are going to locate the highest number of chiral center. In this case, the highest number of chiral center is carbon number 5. For the carbon number 5, we are then going to put the hydroxyl group on the left side. Since it is in L configuration, levo rotatory. Then we are going to complete the structures. Carbon number 1 is an aldehyde group. Next, we are going to complete the structures. Same like what we did a while ago. Hydroxyl group on the right side. Hydroxyl group on the left side. Then hydroxyl group on the right side. The remaining pairs will be hydrogen groups. Hydrogen, 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 and hydrogen. This is now the Fischer projection for D-glucose and the L-glucose, taking into consideration the highest number of the chiral centers, which will determine if it is in D configuration or if it is in L configuration. Again, for D configuration, we are to place the hydroxyl group on the right side. If it is on the L configuration, then we are going to place the hydroxyl group on the left side. Now we have the Fischer projection for D-fructose. D-fructose contains 6 carbon atoms. We are now going to write the structure. On top, we have an alcohol. Same as true on the terminal end. Since there are 6 carbon atoms, let us put lines. So we have here, on the second carbon atom, we have the functional group. Then we continue. So we have already 1, 2, 3. Then we have 4, 5, and 6. So how are we going to make the Fischer projection for our D-fructose? So we are now complete with the 2 ends. They are alcohol. And then we were able to place the functional group, which is a ketone. We are now going to continue our structure. On structure number 5, since we are going to determine the highest chiral center, it is here where we will determine if it is on the right side or on the left side based on the D or L configuration. Since we are on the D configuration, we are going to place the hydroxyl group on the right side. Then, we will continue with the structures starting from the 3rd carbon. Okay? So, for fructose, we have on the left side and then on the right side. We are going to complete the structures. Hydrogen, hydrogen, and hydrogen. Count the number of atoms. 1, 2, 3, 4, 5, and 6. This is now the D-fructose. We are going to do the same for the L-fructose. We are going to write the 2 alcohols on top and on the other end. Then we are going to make the functional group. Afterwards, we are going to continue with the structure. Let us keep in mind that the highest chiral center should be the one that determines if it is on the D or on the L notation. Then for L, we are going to place the hydroxyl group on the left side. Then we will continue by completing the hydroxyl group. So our hydroxyl group will be on the left side and then on the right side. So, after being able to complete this, we will put their corresponding hydrogen. Then we will check if all of the structures are complete. 1, 2, 3, 4, 5, and 6. This is our L-fructose. Next, we have the D-ribose. For the ribose, there are a total of 5 structures. The first thing that we are going to do is to write the functional group. For D-ribose, the functional group is an aldehyde. Then, let us not forget the terminal alcohol. Afterwards, we are going to complete the number of carbon atoms. So we have here number 1, 2, 3, 4, and 5. Let us bear in mind for our Fischer projection, if it is in D notation, then we are going to get the highest number of carbon, and this will be the location of our hydroxyl group. So if we are going to count 1, 2, 3, 4, C4 will be the highest number of carbon that bears the hydroxyl group in D notation. So we are going to place it on the right side. Then we are going to continue the structures for D-ribose. What is the good thing about ribose is that all of the hydroxyl group are located on the right side. And then we may complete the pair. So this is now the structure Fischer projection for our D-ribose. Let us count the total number of carbon atoms. 1, 2, 3, 4, and 5. So the highest chiral center is carbon number 4. Therefore, in the D-ribose, the location of the hydroxyl group is located on the right side. Ribose has 5 carbons, so we are going to continue 1 and 2, 3, 4, and 5. Next, we have to keep in mind that the highest chiral center will be the one to contain the hydroxyl group that consists of the L configuration. So in this case, we have 1, 2, 3, 4. Carbon number 4 in the L notation means that it is located on the left side. Then we are going to continue the structures. I have mentioned a while ago, ribose is easy to memorize because they are on the right side. The only difference is that the L-ribose, the last carbon with a chiral center is on the left side because it is on the L configuration. And then we are going to complete the number of hydrogen pairs. Let's check. 1, 2, 3, 4, and 5. Okay, this is now the Fischer projection of the D-ribose and the L-ribose.